I'm Ben Lee.
And I'm Mason Heberling, and we're from the section of botany. And we're doing research on plant phenology.
Phenology is the timing of repeated life history events. So in the case of plants, we're really interested in the timing of flowering and the timing of leaf out, especially now in spring.
In early spring, a lot of these plants, their strategy is to come up super early, and they come up before the trees leaf out. And in that way, they can capture energy from the sun, get carbon and energy through photosynthesis before being shaded out by the tree canopies.
For many of these species, that constitutes over 50% of their annual carbon budget. So it's like going home for the holidays and eating your weight before then not eating at all for the rest of the year and just kind of sleeping through it.
Thoreau and past naturalists made many observations on the timing of leaf out and flowering across many years, and we can use these historical observational data sets together with historical climate data to see the impacts of how climate influences the timing of leaf out and flowering and other phenological events.
Another really important historical data set is the herbarium collection, such as the one that we have at the Carnegie Museum of Natural History. These are plants that have been collected over the past few hundred years, dried, pressed, and then preserved in our collection. And they all contain information about where that plant was collected, when it was collected, and we can look to see the plant to see if it was flowering or leafing at the time it was collected. This is another source of really important information that we can use in this type of study.
There are almost 4,000 herbaria, which is the plural of herbarium, all across the world. And so we're able to access them digitally, images of specimens and specimen data from museums and universities across the world, to not only look at historical changes in our forests, but also historical changes in forests across the world. In this experiment here, where I am standing now, we are experimentally looking at the impacts of climate change and introduced plant species. Our previous research has found that a lot of these understory wildflowers come up really early in the spring and capture a lot of their sunlight well before the overstory tree canopy shades them out. With climate change, we're finding that overstory tree canopies are leafing out earlier and earlier, while the understory layer is less responsive. Now, all species respond differently to warmer springs, and we're investigating the impacts of that.
For our case, we were interested in how temperate forest phenology, isolated to the northern hemisphere, is changing across different continents. We therefore used herbarium collections that were amassed in Eastern North America, Europe, and East Asia to try to understand how phenology has changed and if we see consistent signals across each of these continents. What we found, consistent with what Thoreau's data showed us, is that wildflowers in Eastern North America are experiencing reduced access to sunlight moving forward with climate change, largely as a result of unequal responsiveness to climate change and especially spring temperature. However, we found very different findings on the other two continents. For example, in Europe, we found that wildflower phenology was shifting at the same rate as the trees above them, meaning that they were expected to maintain their access to light moving forward and not experience the same drawbacks that plants in Eastern North America were. In Asia, wildflowers were actually even more sensitive to climate change compared to the canopy trees above them, meaning that we found that they were able to increase their access to spring light moving forward as spring temperatures warm. This means that in the future, they will actually gain access to spring light and therefore be able to increase their annual energy budgets, which should allow them to perform better. Spring light window duration is tied to the amount of energy these plants can assimilate, which means that it affects their reproductive success and their growth and survival. When plants experience increased access to light, as with the Asian wildflowers, we would therefore expect them to perform better, to be able to survive better, and to be able to reproduce more, and therefore be able to maintain their populations in the locations where they currently exist. In Eastern North America, where these plants are expected to have reduced performance over time, this can lead to their population shrinking and, in worst case scenarios, disappearing across the landscape as a result of climate change.